Hi, welcome to this video. This is going to look at atomic structure and isotopes from the OCR spec of A-level chemistry. And there are 5 sections that it wants to cover in this particular part. And they cover isotopes, protons, neutrons and electrons, relative isotopic mass and relative atomic mass, mass spectrometry and relative molecular mass. So there are just a few key definitions, and if you're taking notes, it'd be worth pausing this and you can get the key definitions down for this section. I'm going to keep on referring back to them as we go through anyway. So first up we have isotopes. Now isotopes are atoms of the same element, so they'll all be, for instance, carbon. So carbon has 3 different isotopes and they have the same number of protons. So their atomic number is all the same, and carbon always has 6, but they have a different number of protons. So we have carbon 12 because it's got 6 protons, carbon 13 and carbon 14. And this is what an isotope is. They're atoms of the same element, so they're all carbon, but they have different number of neutrons, which means their masses are different. Next up was protons, neutrons and electrons and how they all fit together. So in protons, neutrons and electrons, which is going to abbreviate to P and E, we have protons, neutrons are in the nucleus, electrons we say orbit around that nucleus, and if given a compound you have to be able to work out, an element or an ion, an atom or an ion, you get given, you'll have to work out the number of protons, number of neutrons, and number of electrons. So for instance, we'll go back to what we looked at before with carbon 14 and 6. So what we look out for are 3 things. First of all, the atomic number. That tells us how many protons we have. Then we have the mass number, which tells us how many protons and neutrons there are. This is protons and neutrons each weigh 1. So this combined tells us how many protons and neutrons there are. And also this doesn't have it in this example, but we'd look out for what charge we have. And the charge lets us know if what the difference is between the number of protons and the number of electrons. So we'll start with atomic number. Every single element has its own atomic number, and they are arranged on the periodic table in order of atomic number. It very easily just tells us the number of protons. So carbon has 6 protons. Now the neutrons we can work out by looking at the mass number and subtracting the atomic number, because the mass number is the protons plus the neutrons. If we take 14 away from 6 we get 8, and that gives us the number of neutrons. So 8 plus 6 equals that 14. Now the number of electrons, what we have to look at here is that each proton has a positive charge and each electron has a negative charge. The neutrons have no charges. So because this doesn't have a charge, we don't see any plus or negative number up here, then the number of protons must equal the number of electrons. So they perfectly cancel out to give it no charge. So in this case we get 6 electrons. Let's try one with a charge this time. I'm going to look at an isotope of magnesium, which has an atomic number of 12. So there are 12 protons. Its mass number is 25. So 25 minus 12 gives us 13 neutrons. And I can check that. Number of neutrons plus protons gives me 25. So I'm okay with that. And then my electrons. Now I've got charge. And my charge is 2+. So there must be more positive charges than there are negative charges. And each proton has a single positive charge. Each electron has a single negative charge. So if it's 2+, there must be 2 more protons than there are electrons. So I'll have 10 electrons there. And that's protons, neutrons and electrons. Part C refers to relative isotopic masses. And if I go back to my definitions, the relative isotopic mass is the mass of an atom or isotope of the element compared with 1/12 the mass of a carbon-12 atom. So we use carbon-12 as a bit of a standard, and we say that carbon-12 weighs exactly 12, and then we measure everything else around that. So we saw previously 3 isotopes of carbon, and we've got 12, 13 and 14, and that top number is just their relative isotopic mass. Now, in order to work out what the percentages, what the relative atomic mass is, we take an average, and then that will go on the periodic table. Now, if we looked at this and went, well, we've got carbon-12, carbon-13 and carbon-14, let's take an average, and the average will work out that, okay, it's carbon-13. On the periodic table, you'll see that the relative atomic mass is 12.00. It might be 12.01 on some periodic tables. It's pushed way, way further over towards carbon-12, and that's because a huge proportion of all carbon-12 on Earth, of all carbon on Earth, is carbon-12. So I think it's 99%, if not higher, maybe 1% of this, and then tiny amounts of this are on there as well. So we've got low amounts, so we weight it towards carbon-12, and that's why it appears on the periodic table as carbon-12. And we do a calculation for this. And carbon's not a great example to do it with, so we'll choose magnesium instead. And magnesium exists in 3 isotopes that are stable. 79% is magnesium-24, 10% is magnesium-25, and 11% is magnesium-26. And we're going to do a simple calculation to work out the relative atomic mass. And what we do is we take the mass of isotope A and times it by its percentage abundance. So we've got here 24 times 79. That is going to get added to the mass of isotope B times its percentage abundance, and then finally mass of isotope C times percentage abundance. Now it might be and it has 2 isotopes, in which case you just do this part. It might be that it has 7 or 8, in case you keep on going. Mass of isotope D times its percentage abundance. That's going to be divided by 100, because we're doing it as a percentage, and that will give you 24 times 79 plus 25 times 10 plus 26 times 11, all divided by 100, which comes out at 24.3, which is what you'll see on the periodic table if you have a look for magnesium. So part D asks about mass spectrometry, and mass spectrometry can be used, is a technique we use to work out the relative isotopic masses, relative abundances of an isotope, and what we also need to be able to do in this section is the calculation we saw before, that relative atomic mass calculation. Part E is then how we use this information. So we can work out, if we have the formula of a compound, I'll stick it easily with H2O, we can then look at the periodic table and we can see that hydrogen has a relative atomic mass of 1, oxygen has a relative atomic mass of 16. I should say we abbreviate relative atomic mass to Ar. And what we can work out from this is the relative molecular mass, which is described as Mr. So we have hydrogen times 2, because there's 2 of them in this molecule, and oxygen times 1, because there's only 1 oxygen. And so we get 2 plus 16 gives us an Mr of 16 grams per mole. We do it with slightly larger compounds. If we go with this compound here, we've got carbon, which is 12, and 2 of them. Hydrogen, which we saw earlier was 1, and 6 of them in this molecule. And oxygen, which is 16, and we've only got 1 of them here. We get 24 plus 6 plus 16 to give an Mr equal to 46 grams per mole. And that is a very quick run through of the atomic structure and isotope section. If you click on either below or on the PowerPoint, that'll link you to further questions that you can then practice yourself with.